So I want to say hello and welcome to everybody who has joined this session, this talk. I'm happy to see you all. We have a lot of participants here that are going to be listening. So my name is Carolina Loudon, and I'm the president of ATypI as 2 months ago. And I'm so honored. Yay! I'm very honored to be actually moderating this talk that will go into depth to variable fonts, right? Yeah. So you have just joined the session where that is called Amstelvar and the Roboto Flex, unprecedented flexibility and text typography. And everybody's here. I would just make some note that we have a chat that I will be moderating. And David, Santiago, and Dave will be happy to take all the questions in the end. So I'll be sure to check in the channel. So with no further ado, I would like to present and welcome Dave Crossland, who's the program manager from Google, David Berlow, who's the president of Font Bureau, and Santiago Orozco. Did I say that right? Orozco. Yes, type designer from TypeMade. So please start.
All right, thank you, Carolina. Yeah, I'm Dave Crossland, and I'm presenting this work that's been done by Font Bureau. So, while I didn't design these typefaces, I'm speaking to you today because as the lead program manager for type design and font development within the Google Fonts team, I've worked closely with David and Santiago on the development of these variable fonts since 2016. That's when OpenType variable fonts were first announced. And so I'm very interested in the questions about what variable fonts technology actually means for users and for readers. There's some value in what we've seen with thousands of looping GIFs that have been posted all over social media in the last 4 years. I don't want to discount that. But for myself, what I'm really much more interested in is in how this actually is beneficial for users and for text typography. So I'm going to go through this presentation that I've developed with David Berlow, and then we're going to open that floor up to a sort of panel with me and him and Santiago, we can discuss these typefaces and these topics further. Okay, so as I said, back in 2016, I started working with Font Bureau, and we developed these first 2 variable font projects for Google. And these were pilot projects to showcase what the new variable fonts technology can do. And so these 2 fonts were published in early 2017, Decovar Alpha and Amstelvar Alpha. And so Decovar is showing how more than a dozen axes of stylistic variations can be used and abused for display typography. And the way that variable fonts are used in display typography is typically the user, the visual designer, is sliding the sliders around, they're fishing around for what they want. And David had this kind of funny way of describing it. He says, go fish. You're sort of searching around. You don't maybe know exactly what you're looking for, but know it when you see it. So the benefit to the user is that they can better express themselves. This benefit, to express. And in Amstelvar, then this is, a text typeface, and it's a very different sort of typography that it's used for. And with a similar number of axes, both of these variable fonts, these pilot variable fonts, had over a dozen axes. And at the time, this was very unusual. The early days, 4 years ago, most variable fonts had 1 or 2 axes. These had over a dozen. And so the axes that are in Amstelvar are to be used in a kind of coordinated system, and they delivered unprecedented control and flexibility in text typography. And so that's the title of our presentation today: unprecedented flexibility in text typography. So what does that mean? Well, you can think of it as you having the ability to use any point size or any fraction thereof. And we've all had that for a long time now, since the desktop publishing revolution. But along with that, the same kind of precise control that you can have now is there for all the major aspects of typography that affect the visual appearance of text. It means that the body of the type, the height and width of the negative spaces, and what we call our transparent shapes, as well as the typeface itself, the positive spaces, what we call the opaque shapes. The lengths and widths of stems, the hairlines, the terminals, the serifs, and other forms of, other type forms. All of these attributes can be changed independently of each other or in concert together. And that's because each is being put onto its own variable font axis. And in having a focus on only one visual aspect at a time, or a parameter, we call these axes a parametric axis system. So the way that these axes are used is typically that the user, the visual designer, is not sliding the sliders around to set the axis positions. Instead, there's going to be some kind of logic that's going to be used to figure out what the values of these axes should be based on querying the context of the type and the typography. And so David also had this funny way of describing this in the early days. To contrast with go fish, he said, go figure. So for me, the benefit of the user here is that they can finesse the text. With this stuff, you can achieve better typography for traditional and modern composition. So here's some different sort of text settings. In the old days of metal type, users could order from a foundry something like this on the top left there. 12-point type on 12-point spacing, or 12-point type on 13-point spacing, and reducing the spacing couldn't typically be done in metal type. You could only add more space until photo typesetting technology. And there's that Helvetica documentary a few years back, and there's a really nice book that was published along with the documentary by Gary Huswit, and it was made to sort of provide all of the depth of the interviews that they did with all of these people that were featured in the documentary. And the first interview in the book is with Massimo Vignelli, and he's explaining that one of the main reasons that Helvetica's popularity was, sort of so stratospheric at that time when it first came out in metal, was that it was cast with almost no side bearings at all. And so you could, if you were kind of a trendy designer at that moment, then you could get your type reduced, but at great expense because it meant filing the metal type down. And so with Helvetica, you didn't need to go through that trouble because you could add the space that you needed, precisely. So, today digital type, since the desktop publishing revolution of the 1980s, then there's been so much more flexibility in design applications that's been available for this additional kind of fine control of type size. So you have tracking, line spacing, word space control, and of course, such a huge selection of typeface styles within a family, and the explosion in the number of families themselves that have happened since the 80s. But it's only with variable fonts that the full fluid range of all of these things in the typography application settings and in the fonts themselves can finally become a reality. And so that's really, what makes this unprecedented. So I'm now going to hand over to David to talk about this sort of progression from pre-digital type to what is only now possible.
Thanks, Dave. So this is kind of a rehash in slow motion with some synthetic metal type in front of you of sort of how we went through this process. And in most metal type, the glyph was struck by a punch into a mold that was used to produce the font. And the glyph and its space, or the metal around the glyph as it ended up, were physically separate until the font was made. And the user could order different sizes on the M of the type, as well as different spacings, in order to avoid and save the work of working with, the way Vignelli is talking about was hopefully for display type. But if you were sending text type, you couldn't be dealing with, hundreds or thousands of extra little tiny pieces of metal for leading and letter spacing. And it just slowed things down immensely to have to work that way. So book publishers and others who used common sizes would just go ahead and order them to those sizes from a typehouse. And then as soon as people got digital type, one of the first things they did, they started scaling it horizontally a little bit to save paper, because by then, if you were the publisher of a major newspaper in the United States and you just condensed your type 2%, you could save $50,000 to $100,000 a day in paper costs. So most of the digital fonts that we came across when we first started moving these into a PostScript were being used with a scaling factor on them, as well as quite often a tracking factor. Oops. And then with variable fonts, you have this other option, which is you have this great bundle of registered axes like weight, width, and optical size, along with what applications allow type to do with sizing and tracking and line spacing, all in tenths or hundreds of points. And this allows all kinds of flexibility among the common variables and the common variables of typography. Both fonts and typography can be mixed together in this way. But there's still more that can be done. So with variables, once you get that, I mean, with parametric variables, I think I double titled that. It's supposed to be variable parametrics. But when you have parametric axes, you have the ability to change one thing at a time, which also allows you to finally change the width of the characters, which you couldn't really do in digital type without changing the weights as well, because when you scale horizontally, that scales everything. But now with variables, you can just scale the contours, and with tracking, you can just do this other kind of spacing change. And so you've got independent control over these, which is very, very powerful. And with that, I'll turn it back over to Dave.
All right. So what you've just been seeing here is the latest Amstelvar. And everything that David just talked about was being demonstrated in the original Amstelvar Alpha, from 2016. So what have we been doing for 4 years? Well, the last couple of years, we've been working to take Amstelvar all the way to a fully production-ready kind of 1.0 release, and have true italics in there. And what I found, when I was working with the Alpha, with the early versions of the sort of full Amstelvar project, was that as a serif face, what I really needed to work with it was a companion sans. The sans and serif are the fundamental genres or design classes, as David would put it, of Latin typography. And so the last years, David's been working with me and Santiago to envision what Roboto can be like as a parametric variable font. And so today, Amstelvar and Roboto Flex are this pair of font families, which are, OFL, Libre licensed, anyone can use them to explore this new kind of flexible text typography. So each of these families has a very broad range of weights, from super hairline to super heavyweight, so extra black. And they also have a very broad range of widths. Oops, again. So, a generous range of widths from condensed to expanded. And you're seeing these, together as a sort of, as interrelated. So these two axes, weight and width, these are the most important axes. They're most fundamental to, typography. And if you want to go fishing with sliders, these are the most expressive things, because when you have this wide field, there are many sort of atmosphere values or voices that you can tune into. And so here on this slide, you're seeing the 144-point design, but it's probably been scaled down for you. It's unlikely that on this web platform, you're seeing it at 144 point. And so David has this interesting term for this phenomena, that when an optical size design is being scaled down to another smaller actual size, he says it goes past the vanishing point, or sort of over the horizon. And I'll come back to this point in a minute. But first, let's look at how, when optical size does go down in tandem with size, what happens. So here's the 14 point. So we've jumped down in size to the default for these fonts, and the sort of edges of the design space have been shrunk. And the practical meaning of this is that the legibility of the letter forms has been reinforced. So I'm just going to toggle between the two here, so you can sort of see that jump. And so as I do that, you can see that the bigger, most obvious change to Roboto Flex on the right is in the minimum width styles, the left 3 styles. And, there's a big jump there that's really dramatic, because at 14 points, those 144 point designs would just be completely illegible, completely just, falling apart. They would be it would be impossible to read them. And at 14 point, the range of widths that it's going to be comfortable to read is narrower. And then you also see on the bottom row that the minimum weight at 144 point is extremely thin. And scaled down, if you're seeing it scaled down, you may even see it sort of breaking up. The line quality may be, sort of uneven because of the way that the scaling is happening. So at 14 point, it would just disappear. You wouldn't see that line whatsoever. And so for the 14 point optical size, then these thin strokes have become thicker and, sort of bulked up so that they remain completely visible. And so similarly, Amstelvar, there's that reinforcement that's happening in the stroke contrast primarily. You can see that the thinner strokes are becoming a lot thicker, and so they don't disappear in the same way. So when I'm looking, at these optical size differences for myself, I can sort of more clearly see what's happening in Amstelvar in the details, because the sans has this sort of purity of reduction, simplification of form, and that can kind of obscure what is actually happening in a way, because it's, the change has been pared down to something which can be extremely subtle. So another important idea about optical size is that it should, by default, be applied automatically all the time. And so remember a minute ago I said how weight and width are about that kind of express benefit. Well, for optical size, this is the primary axis that I see for the finesse benefit. And that's because the way that this should be typically used is you forget about it. You set your size, in points or pixels or whatever. And then there should be some logic that figures out what that means in physical points, and thus what the optical size axis value should be. And there's some nuance to this. A lot of systems at the moment are just taking the size value and applying that to the optical size axis. And it might be a pixel value or, just a size number that's totally untethered from anything except itself. So there's some nuance, around how this optical size automation should be done. And another way that is nuanced is if your size is bigger than what the optical size axis allows, then you want to clamp to the minimum or the maximum value. And I mention this because a couple of years ago, in one of the first implementations of this, in an operating system, then what happened was when the value was outside the axis range, then it snapped back to the default. So, you'd be going 143, 144, you'd be seeing something like this. You go 145, and it would snap you back down to the default like this. And so, as a user, when this automation is set up, then you just completely forget about it. And I think that's very powerful. That's a real benefit to users, that you no longer have to think about the way that you track your type in or adjust it for different sizes, because all of those adjustments are being done automatically. And there's one other point that I want to make here about optical size, and that is that every type style has an optical size, even if it's not a variable font, even static fonts, every font. In the same way that a Latin font will have a cap height, every typeface has an optical size latently, and the way to determine what that is maybe something for another presentation. So for these 3 axes, weight and width across the optical sizes, that they sort of work together in a 3-dimensional space, which is easy to visualize. So you have your width across and your weight up and down, and then the size is sort of nearer and farther from you. And I think that's a good way of ordering those 3 axes. And there's quite a lot of typefaces that have this design space, that have this sort of system of styles. And I want to recognize that in these 2 typefaces, Roboto Flex and Amstelvar, the extent of this stylistic system is very large. And it's forming this huge foundation for what we want to focus on in our presentation today. So building on top of this core design space of weight and width and optical size, each of these families contains more axes, and these allow fine-tuning of one aspect at a time, and that's why they're called this way. They have this focus on one aspect or parameter, so that we call them the parametric axes. And they're in these fonts, but you may find that you don't see them immediately, and that's because axes can be flagged to be hidden from the user by default. So you may have, in your app, there's be some kind of progressive disclosure UI pattern, so maybe a checkbox that says show all axes or something like that, to actually get at the sliders for these parametric axes, because they're not really meant for sliding around on. They're meant to be set in this very precise, logical way, but they are there. So you, in order to figure out what that logic is, obviously you'll need to use the sliders. So today we're going to demonstrate just 3 of these parametric axes, and then the 4th axis we're going to show you is a special kind of axis that allows slight adjustments to apparent weight without any changes to width. So in text, there's no reflow, and that's an axis that we call grade. So these axes are giving like a foundation for the historical use of type. So the reading of it with a range of possible geometries and a range of tones of voice over a range of distances. And so, as I said, optical size is best thought of in that Z dimension because it's really for handling, or it's related to that range of distances. So what makes smaller sizes readable in longer passages is complicated, and it's complex for several reasons. What makes type larger more readable is more obvious. So a small text has a narrow range of the closer distances that a user can comfortably or even successfully view it from, which is maybe, sort of 8 to 24 inches, here in the USA using inches. And, sort of closer to your nose than that, you can't comfortably see anything clearly. So yeah, closer to your nose than that, you can't see anything clearly. It's not about comfort. It's literally, being able to see it at all. And then further than that, you can't really read super long texts comfortably. And large type sizes can be read from a much wider range of distances. Here in the US, maybe 4 to 20 feet. And so, yeah, it's for text typography, what we're looking at is what's most relevant to that longer text, that immersive reading experience, and those smaller sizes, those smaller distances on the left. And so what that translates to today in terms of digital media is that while type may be used in a wide range of geometries, from a massive cinema screen down to a phone, even a watch face, the issues that are really concerning us are with these sort of typical device sizes. And so these screen sizes, from phones to sort of large desktop displays, that's what the kind of reading experiences we're focused on. So, an important thing about longer text is that it's split across many lines in a paragraph or paragraphs. So the reading experience is determined not only by the font and the negative spaces or the transparent spaces inside the font's design, but also these negative spaces, these transparency parameters outside the font, and that these shape the paragraph or the column. And so that's the character count, the line length or column width, the line spacing, and additional inter-paragraph spacing, the letter spacing and the word space width, and then the hyphenation justification settings. So these are all sort of transparency parameters that are intrinsic to the typography outside of the font. And these can change over the course of a text. And that's because, longer text documents, they're composed, they have different kinds of text that are all treated differently. And, the sort of body text is going to be laid out amongst these other page elements. So images, graphics, user interface elements, and so on. And this is challenging the visual designer, the composer of the typography, to maintain the reader's interest and comfort in that body text. So what we have in Amstelvar and Roboto Flex are these 2 font families that can help us to explore more flexible modes of composition of text by relying carefully on variations within these kind of well-known genres, or David calls design classes, rather than introducing a new aesthetic on which to demonstrate. So these four axes that we want to dive into are the optical size axis that we've been discussing, and then the Y dimension transparency around the descenders, so under the baseline. And the axis code for that is YTDE, the Y transparency descenders area. And then the third axis we want to discuss is the X dimension transparency overall within the font, the XTRA, the X transparency axis overall. And fourth is the grade axis, GRAD. And you'll see these. The first one is lowercase. The others are uppercase to indicate that these are these custom axes. So these are not part of the OpenType specification, and these are axes that have sort of been standardized at the Font Bureau type network, and will be introduced into Google Fonts. That's our intention. So for each one of these here, you can see that the default design, the second design shown is the default, which is in gray. That's the 14-point design. To the left of that is the minimum for the axis. And so for optical size, that's an 8-point design. And then on the right edge, the fourth sample is the axis maximum, so the 144-point design. And then in between those is that third style, which is interpolated, which may be, say, a 36-point design. So for the Y dimension transparency around the descenders, you can see the P descender is very, very long, on its sort of minimum value going down, and then very, very short and stubby on its maximum values. And the difference between the default and the interpolated is quite subtle. Then on the XTRA axis, the X transparency axis, then you can see that the counterforms inside the letters are changing their width. So, the counterforms are getting much wider, but the strokes are not changing. So the stem width is staying completely consistent. And so it's not exactly a width axis where you would see not just the counterforms getting wider, but other things happening to the typeforms, both in their transparent and opaque shapes. And then obviously in grade, it's a little bit harder to see it laid out horizontally like this, but the overall width of those four characters is not changing. So as the apparent weight is increasing, there's no change to the width whatsoever. So that's Roboto Flex, same thing in Amstelvar. And so I'm going to hand back over to David now, and he's going to demonstrate some examples of how these parametric axes are being used.
Thanks, Dave. So if I just pick a single optical size, like 11.7 from the optical size axis to these fonts, that's what it looks like in, you can see what it looks like view. In actual size, set up on the geometry that they've asked for this presentation, this is your 11.7 point. So we had to sort of make things a little bit bigger so you can see, I hope you can see, if you have the chance to make your window bigger, the bigger you make it, the better you can see it, which is kind of like getting closer. So if you decide that you're going to have a column width of 48 characters with room to breathe, which means that the eye can quickly and reliably hop from the end of one line to the start of the next line, and with an appropriate descender length that avoids collision, typically leaves you with a few options on how to treat lines, ragged or justified, with or without hyphenation. So the demonstrations that I'm going to show you sort of follow them all, each one of those along. I'm going to drop the optical actual size, and we'll just be using these two sizes to look at. So here is the default at 48 characters wide at 11.5 point, 400 weight, normal width. And you can sort of see that there's a way that you could make the descenders a little bit longer and they wouldn't really get close to crashing. And on the other hand, they'll sort of help break up that big white space between the letters and help people get back and forth, it's said. So here we have a slightly longer descenders, and if you go back and forth between the two, you see I'm showing the longer descenders on the right, and between the lines there's now like more space being occupied, and it just feels a little bit better to have that extra length on the descenders. And this used to be quite common until people wanted to save as much money as possible, and they really stopped having multiple descender lengths. So in the next demo, which is XTRA, we start out with a simple justification scheme that is none. There's none. It's just left aligned. It's the same size, multiplied by 3. But if we do want to justify that, standard justification is going to do that, which takes you from something that was easy to read in one way, but it was hard to find your way back from the end of the line, perhaps, to something that is easy to find your way from the end of the line to the next line. But the word space is starting to conflict with the line spacing, and that's never very good. I mean, when the space between two words is bigger than the space between two lines, the person starts to get lost. So this is a version where each line basically is saying, do I need to get shorter or longer depending on what the next word in the line is after it was broken from in the first place. And then decisions are made about how to spread out the change, whether it's becoming narrower or wider, but spread that change out among the word space, the letter spacing, and the counters of the forms of the letters inside. And so doing that, by a fairly simple algorithm, you can actually reach this almost unhyphenated kind of justification, or you can reach a point where all of the lines are within a percentage of fully justified, so that you're reducing the amount of raggedness on the right, but not at the expense of any other aspects of the typography. And so we have here the 11.7 point type. We have the same line spacing. We have the same column width. We have everything is exactly the same, but I'm making tiny changes that are extremely hard to see between the two versions if you see them next to each other. So individual letters basically don't look like they're changing at all, when in fact everything on the page basically is a different, every line is basically a different X transparency value. So that's the automatic justification, which you can see is also taking up a lot more space versus the XTRA, which is a lot smoother. Then our third demo is how we do what we do with grades. And on the left column, you can see that there is a fairly narrow range of change without the layout changing at all. And we're looking for feedback right now from operating system developers and users as to how this should be adjusted. I've seen both serif faces with finer hairlines that tend to lose their readability when they change into dark mode, and I've seen sans serif faces that seem to get too bright. when you go into dark mode. This is a challenge. It was a challenge long before dark mode. Font Bureau did some research and development into this a long time ago. And as I go through these quickly, maybe at the end Dave will tell about that. But this is grade minus. It's almost impossible to tell the difference, except that there's just a slightly less bright feeling. And on the right side, if you look closely here, you can see the difference has been, it's just this tiny little red hue around the letters. And that's all that the changes between these two grades. Dave?
All right. Well, yeah. So, yeah, this fourth axis grade with optical size variation, you have the line spacing, the letter spacing, the word spacing, that are all adding flexibility to composition. But a lot of content, digital content, also has to respond now to dark mode. So it's not just the the composition of the container, kind of responsive design. There's this new aspect of you can be in this dark mode, and the quality of the typography, text sizes, is very sensitive to foreground and background contrast. So an axis that can change that without disturbing layout is very useful for digital typography today. And so this sort of challenge, I think is something that's very contemporary. But this kind of variation is something that had been developed at Font Bureau back in the early 90s, when this was TrueType GX technology, not OpenType variations technology. And so the sort of story I heard from David and Roger Black was that they were working with a print magazine publication, and it was made by binding two different kinds of paper sheets together. One for the full color pages with a lot of photography, and one for the black and white pages with the long article texts. And so these different papers required different printing presses and different kind of ink chemicals. And all of that combines to, absorb, the ink absorbs into the paper differently. There's different ink viscosity there. So the same font, digital font, being used black and white without changes to the color of the ink, without changes to hue, is going to result in a quite different impression on the reader. The foreground background contrast is going to be quite different, even though the font itself has been the same through these different print processes. So what Font Bureau did was to create different fonts to normalize those differences, enabling the art directors to move a paragraph from one page to another and keep the same even paragraph texture, because the font was changing to create the same result. And so at Font Bureau at that time, they decided to call this kind of variation grade, as in the grade of an oil, because it was sort of related to the ink viscosity that was being used. So today we're not dealing with paper media, we're dealing with digital media, but this axis is still extremely useful for a totally different kind of challenges.
But it'll still work in print.
Yeah. So we're looking at grade for dark mode, and this whole presentation has been this white text or light text on a black or dark background. And what's happening when you have that is there's this kind of glaring. So if we toggle back between these two slides, it's very subtle. But when we go here to so here's kind of grade default in the actual size ×3. And then when we step to grade minus, it's very subtly getting lighter, and that's reducing the glare. Before grade, you may have been doing that by setting the hue, by changing the color of the foreground, text, and that is changing the overall contrast. And I think that this is a more sophisticated, and potentially this is going to be a sort of way that we can maybe use some reading science to prove that this is a better experience. Okay, so yeah, thanks David for taking us through those. So this presentation, we're going to have to jump into questions. So for you to learn more about this parametric axis system, I want to tell you about 4 things which Font Bureau has published in the last 4 years as part of our commissions. And so there are sort of 2 tools and 2 brochures which are going to go into more depth on the ways in which text typography has this new unprecedented flexibility. So I'm going to try and use this platform to share my screen and quickly take you over that. So let's see if I can do this. I'll stop sharing. Application window. All right. So yeah, so the first one here is the type tools, typetools.typenetwork.com. And many foundries have found that to develop variable fonts, they needed to imagine new proofing tools. And a few of those have been made available to others, such as the Dynamo Font Gauntlet. So I commissioned Font Bureau to develop not only these typefaces, but also the tools that they needed to make them. Which they would have made anyway for Type Network, but for since we were commissioning these fonts, we wanted to make these tools for proofing and developing the fonts freely available, on GitHub under a Libre license to all typeface designers. So typetools.typenetwork.com is this set of web page tools for exploring all of the styles inside a variable font. And this is something that I myself use as a font user almost daily for checking what is inside any variable font design space. But it started and it remains a central tool for type designers at Font Bureau. And so you can see when you first visit it here that there's an introduction that's fired up, and this sort of steps you through the interface and explains all the different features there. So you can see we have some preloaded families and so on and so on. So there's these different layouts here, and there's this sort of grid layout, which I think is quite useful. So let me change the window. Okay, so you can see you have this grid layout, and you can sort of see the weight and width grid, next to each other, and then you can take it through the optical sizes. So you can see how those are changing as you move through the optical size space. And so, yeah, it has these preloaded fonts, and you can click to add your own. You'll get a file drop dialog to do that. You can also just drag and drop them straight into the browser. If you want to see dark mode, we can flip the colors over, see how that works, and adjust the grade appropriately. And yeah, this is very, very useful tool. So the primary layout, the ramp, is for setting these sort of paragraph and headline type styles. And that's it's very, very useful. And it has a kind of precise control. There's also these flags so you can see the axis values that you've set or not. Okay, so the second tool, which is sort of much more relevant, directly to type designers, is video proof. And the video proof tool is something which was needed for developing these typefaces, because when you have such a large design space, so many weights and widths across so many optical sizes, there's like millions of instance glyphs to look at. And using a traditional proofing system, like making documents in InDesign or Drawbot or what have you, that outputs a PDF, well, with this many styles, you wouldn't have time to look at everything. Your document would be, just thousands and thousands of pages. So it's just impossible to compare things with so many pages as well. Now, years ago, animated movies were made where every frame was being drawn, and they also took years and years to produce. So I think what's needed is to speed up the rate at which you look at everything by using techniques from animation. And so that's what video proof does. It allows you to set up your design space locations as keyframes along the left here. And then, you have a play button, and you can set the full cycles time. And so you can see that in 54 seconds, it's going to run through all of these keyframes.
If you want to speed up, you can put it like 12 or 10 seconds, and you can see the complete space faster.
There we go. So 10 seconds.
Yeah, I love video proof.
Maybe it's too fast.
Yeah.
But as a type designer, you can get some coffee, you can sit back, you can say you want to see it over 60 minutes and, see everything carefully going, and when you're in, that kind of trance you get when you're staring at proofing sheets, you can see how your millions of styles are coming along. Okay, so this is really for type designers. Going in the other direction, then we have these sort of brochures. So we have these two brochures, which are for the users of fonts more than the type designers. Although I hope, like this presentation, that this can help address questions. The big questions I hear from type designers about parametric axes, about what are they useful for. So the first brochure is at typenetwork.com/brochure from 2017. And there's sort of two main parts. The first thing is, this three-part series of essays about the historical context of variable fonts. And then the second part to it was some sort of release pages for Amstelvar and Decovar when they first came out. And this sort of deeper background thinking on variations technology, I think, is really important context to have. But it's a little bit abstract, a little bit academic. And so the subsequent brochure that we've developed is at variablefonts.typenetwork.com. And this was published last year. What you can see down the left sidebar is that there are these sections for the major topics of text and type and typography. So you have different scripts talking about families, styles, size, spacing, those looping GIF animations, grades, each of these sections has a sort of introduction to the topic that summarizes it before variations, then a primer on how it works post variations, and then a couple of demos. So we've taken you through today this presentation of spacing. So we have a spacing primer here, and then we have some explanations of how spacing can work responsively. And then we have an interactive example of this justification. And so you can see this is still using Amstelvar Alpha, and you can set the size, you can set the weight, and you can set the column width or line length. And then you can see how the justification's working with the word space only, with word space and letter space adjustments, and then with XTRA, sort of what we call X transparent or kind of parametric width adjustments. And so all of these sections have got these interactive examples to explore. And as you can see at the bottom, all of this stuff is on GitHub. So in the github.com/typenetwork area, then you can see we've got these repos. And the fifth one is the axis variations proposal, and that is at variationsguide.typenetwork.com. And this is going through all of these parametric axes. Okay, so I think we can open the floor now to questions. Thank you so much for watching our presentation.
I just want to add that all that was done by Chris Lewis. Thank you, Dave.
Thank you so much for your presentation.
All right. Well, so we've got 10 minutes for questions.
Yeah, we have some questions. So the first one was about the parametric justification script, if that was available in the Roboto Flex repo, which I think you answered, right? That's for Mirko Velimirovic.
Yeah, exactly. So the brochures, all the sources, all up on GitHub, and there's a link in the footer. So variablefonts.typenetwork.com, and you can check it all out.
And then there's a question from James Lucas, and how close are we to having Adobe Paragraph Composer take directly control over an extra axis?
Yeah, so the XTRA, the X transparent axis, is it's there in the fonts, and if your software, your typesetting environment has variable font support to set axis values, then if they're expressive axes, use the sliders. You see it, it when you see it. For these kind of parametric axes for finessing text, then you have this system to determine what the value should be, and you can express that system in code. So in a web browser, you have your JavaScript scripting, and in InDesign, I believe also the scripting is written in JavaScript. And depends on the API of your typesetting software to what extent you can get down into the text. So on the web, we actually have to take each line in the paragraph and break it up to take control over the paragraph setting and handle it a lot more, kind of manually. And it may be that you also would have to do that if you're, trying to do this with Adobe. You could, sort of develop your own Adobe plugin that would, take care of this stuff. And as for, it being a sort of an actual feature in the application, well, we've published all of the information about all of these axes. We invite everyone making type tools, to sort of use these. We would like to see a lot of type designers, seeing the benefits to their users of parametric axes, and seeing this become a kind of industry standard. Font Bureau has been working with Google Fonts on this. Everything's open because we really believe in the value of this. And if this was like a Font Bureau only thing, myself, I would see that as as a pity, because that would preclude stuff like an Adobe Paragraph Composer kind of feature. David, do you want to speak to that?
Well, I agree, and I think that there are a lot more scripts in the world that need a lot more sort of scripts that are closer to calligraphy and in their historical forms. I think should have more of this stuff, because that's what they're about. They've been frozen in this Gutenbergian one letter fits all, and even if there are a lot of letters made that are combinations of other letters now for open type features and stuff like that, but that doesn't really cover everything that goes on with all the scripts in the world. So I think that to a certain extent, we've sort of had all of our typographic expectations tamped down by having Latin and having these sans serif typefaces that really don't need as much stuff as other scripts do. So.
Yeah, there's a question about scripts, about automating in CSS, but you said JavaScript, Dave. I was actually thinking about more of the support also for those scripts being rendered in browsers, etc.
Yeah, well,
I think that's maybe the question actually about automation, automatic. Yeah.
Yeah. So in the web, in the web platform, there's this effort, I think it's called Houdini, right, which is aiming to give more access to the underlying browser rendering environment from the scripting JavaScript layer. And there's some very exciting stuff happening there. Let me see if I can pull up a quick.
While you're looking at that, I think it's important that you have to have the fonts first. You can't start out saying, I'd like to have this thing, and then somebody says, what does it look like? And then you're saying, well, you're going like this with your hands, and it doesn't make any sense. So we've gone ahead and made fonts that probably does more than most people need. But they provide this test bed where we can test things to see, how far a grade should go, or how much XTRA is, or how that changes over optical size. And we've done some work with other scripts like Cyrillic, Greek, and Thai to also see how they use these things, and that's what we're getting to, starting to get a bigger and bigger view.
Yeah, I would like to add something. All these axes are for balancing the black and white of the letter forms, and different scripts have different densities. Like CJK, they need some lighter forms to match the Latin, and that's why all these axes work to finesse all this type text.
Yeah, I have one question, and that would be, I think that's the last one. Oh, where did it go? Will AI be used to setting type in a highly bespoke manner using variables in the near future? What about variables in a non-Latin script? Well, I think we have answered some of them, but do you want to?
Yeah. So for the AI aspect, I think that what we're talking about is sort of much more modest, right? Is that the old days of AI before the current large neural net stuff was these sort of heuristics, right? And so what we're talking about, like I in the presentation talked about, there's this nuance to setting optical size automatically, and there is a CSS property, font optical sizing, and the default value is auto. And so in all the major browsers today, if you use a web font with an optical size axis, the axis value is going to be set automatically. Now, there's some quibbling about exactly how that works. In my opinion, it's not being done correctly by the browsers because they're not translating the size values to physical points correctly. But that's the idea, which is that it's on by default. Its optical size is automatic. If your font has an optical size axis, it's going to be used appropriately. And there's this heuristic around the ends, right? That if your value is bigger than what the axis has, you should clamp to the end value. So this isn't exactly AI, but it's a heuristic, which is adding some kind of typography intelligence into the environment. So this kind of big data stuff I wouldn't really see as being relevant, but we definitely do not have a very convenient or established way of developing these heuristics or these sets of rules for the typography. And I mentioned a few times, David has these great words to describe these things. And so the last year or so, David and I have been talking about what he called runnions, which is this sort of portmanteau of the text run and an onion, like the layers of the onion. So you have these different rules that might say, okay, the size is this, so set this optical size axis value. And then we're in dark mode, so set this grade axis value. And those things are happening, at segmented layers of the typography.
So this is much more like an expert system than AI, in the terminology that I escaped AI to get into expert systems, right? To use that term instead. And I think that when you're talking about type and typography, it's more complicated because you've got an expert making suggestions only in web code, and then you've got the ultimate expert who is the user. So it's not like typical expert systems where there is immediate feedback for the person who's actually using this thing. And so that's what I think is going to have to happen. I think that there has to be some amount of expert system development for things like dark mode in general, or watches, as a user interface platform. But then it comes down really to the user, because we have distance and we have age and we have eyes, and it's a biological function, right? So you can't AI a biological function unless you can poke them in the arm or something and get their blood type and everything else, and then call their optometrist. And it's just like, how far can you go before you're starting to intrude on their private space?
Okay, I think that's good. The private space, the conference space that you had, the conference room that you have as a slide in the beginning of this presentation, that's actually the same as the desktop here, I think. So we're probably going to see a lot of going on in the future. But I think I'm going to end. I think so, yeah. And I would like actually the people who are participants here to either go to the Hangout room, which you find under the agenda tablet, and continue talking. And I hope that some of our speakers will be there, or they can attend the calligraphy demonstration that will be available. Okay. Thank you so much. Thank you, David. Thank you, Santiago. And thank you, David.
Thank you.
I'm sorry.
Thank you, everyone.
Yes. Okay. Thank you. Bye-bye.